Hello, I am audible. Please confirm, Sirat. Okay. Okay, let us start. So, the first question is the sum of the component of the pressure and wall shear force in the direction of normal to the flow is called. The option A is drag, B is friction, C is lift, and D is the bulk. So, which option is correct? You can comment in the chat box. So, yes. So, you can write your answer in the chat box. So here we are talking about the component force of pressure and the shear force in the direction normal to the flow. Let's suppose a body is a and air is flowing like that. So the component, normal component as well as your here two component will be, and this is your resultant. So we are asking about these things. The question is asking about this component. So now you can, okay. Okay, you are telling B option, but you can think once. Okay, now let me explain. So if air is flowing like that, or you can say the fluid, so this component will be your lift and this component will be drag. So the answer of this question is C. Now here is some explanation. You can see here the sum of the component of pressure and wall shear force in the direction normal to the flow is called lift. Lift is the force acting perpendicular to the direction of flow, which is typically due to pressure difference across the body or a fluid element. So drag, you know already, drag refers to the force acting parallel to the flow direction, and friction is a resistive force caused by shear stress along the surface, whatever the surface was previously I have drawn. So along the surface, whatever the shear force acting, that is the friction thing representing, and the bulk is related to the shape of the body and its effect on flow separation, not on force itself. Now the next question is very interesting, so you can take 5 minutes for question number 2. The manufacturer of a car reduce the drag coefficient of the car from 0.38 to 0.33 as a result of some modification in its shape of the design. if on average the aerodynamic drag account for 20% of the fuel consumption, the percent reduction in the fuel consumption of, of the car due to reducing the drag coefficient is. This is a practical question. If you will think, just you have to remember for this question the formula, drag formula. Then after that, if you remember this drag formula, then only mathematics required for this question. So please you try to solve. Question number 2. Option D. Let me show you the option D. Yes. So the option A 1.58%, option B 13%, option C 6.6%, and option D 2.6%. So you have 5 minutes, or you can take more time, because this is very important question, practical question. Then I will explain in very easy way. So now let me discuss. So if you have any answer, you can. Okay. So the question number two. So in question number two, actually, the previously, let us suppose a car is here. A car is like that, moving in this direction. So for this car, your drag coefficient is 0.38. After modification, this car, it might be modified like that, maybe like that. After modification, your CD is, let us write here CD1 and this is CD2, is 0.33 in this question. Now, the fuel consumption, by two things. One, basically for weight, of your maybe vehicle as well as your body. And now another fuel consumed by due to the your drag, that is CD, I will write here. In question given 20%, your fuel consumed by your drag force, and another 80% consumed by your weight. So here just try to understand 0.38, let us suppose 100 liter your oil, that is fuel. In 100 liter, 80 liter required, for your weight and 20 liter required for drag. Weight and 20 liter for drag. So what you will do here, that is 0.38 is taking how much? 20 liter. Now that is, this is CD and this is fuel. Now 0.38. Now your 0.33 how much take? 20 divided by 0.38 into 0.33. So this much liter is taken by when your drag coefficient will be, let me just write here, it should be less than 20, because as your drag coefficient is reduced, your fuel consumption will be reduced. So let me just calculate. 0.20 divided by 0.38 into 0.33, it will become around 17.36 liter. Right. Now how much reduction? that is the fuel reduction. Previously was 20, now 17.36. 20 minus 17.36, 17.36, it will come around 2.64 liter. This much amount reduces. Now percentage reduction, previously your fuel consumption was 100 liter. Now the difference is 0.64 into, if you want to calculate in percentage, it will come around 2.64%. So like that you need to calculate. Remember please how you will calculate. So here overall idea, because 80 will not change because this is by weight, and only changing occur in your drag things. So that's why I have here subtract only the drag one part. So now the next question is, so hope you people got it what I was trying to. Okay, next question is, if the flow depth remain constant in an open channel flow, the flow is called uniform flow, steady flow, varied flow, unsteady flow. So please try to give your comment in the chat box for question number 3. For question number 3, please try to give your answer in the chat box. Very easy question. If the flow depth remain constant in open channel flow, the flow is called. Then I will discuss all 4 points. What is uniform flow, steady flow, varied flow, and the unsteady flow. So please try to give your answer. You have 2 minutes. Within 2 minutes, please try to give your answer. After this class, we have one extra classes, maybe on 16. The NPTEL team will intimate you through your mail ID. So it might be on same time. We will see. Okay, you are telling option B, steady flow. Okay, let me discuss. So, if the flow depth remain constant in an open channel flow, the flow is called, it means, what is the actually meaning? One channel is there and water is flowing. Remain constant in the open channel means here if depth is 1 meter, here also depth is 1 meter, here also depth is 1 meter, right? So such type of flow is known as uniform flow. What is a steady flow? Let me discuss. Steady flow is nothing but, okay, if this is flow depth, at a particular point, your flow is 1 meter. Let's suppose T is equal to 8 am. T is equal to 8:30 am. Depth should be 1 meter. It might be here 1.2 meter at 8 am. T is equal to 8:30. It might be 1.2 mm. At same time, in the same channel, it might be chance to water level difference. But in steady flow, we see at a particular location, at a particular cross section, that is your flow characteristics, if I write with F, should not be changed with respect to time at a particular cross section. But in case of uniform flow, your flow characteristics should not be changed with respect to distance at a particular time, at a particular time. Remember please, at a particular distance, that is distance is constant. So remember always. Now what is varied flow? Varied flow may be two types: gradually varied flow and rapid varied flow. Gradually varied flow means what? Let me give you example. Let us suppose in a river one dam is constructed here, like that. Dam is constructed, so water level maybe varies like that. So this is your gradually varied flow. Below the dam, what happened? Water level come like that, and then after make jump, then so here is depth like that, here is depth is very much, here is depth is very within short length, your depth is changed comparatively more than if you look here within a short length. So this is your rapid varied flow. Remember please. An unsteady flow, if you're at a particular uh, location or particular cross section, your flow characteristics should not, if change with respect to time. Let us suppose here at 8 am your flow depth is 1 meter, at 8:30 am here flow depth is 1.5 meter. So such type of flow is known as unsteady flow. Always remember please. Now we'll move on the next question. Next question is one numerical, very short numerical. So Water flow in a rectangular open channel with 5 meter at a rate of 5.7.5 meter cube per second. The critical depth for this flow is 0.54 meter. 5 option B 2.5 meter, option C 0.61 meter, option D 0.96 meter. So please try to give your answer in the chat box for question number 4. Very easy question. So after 2-3 minutes I will solve. So please try to solve and try to give your answer. Try to write your answer in the chat box. Which option is correct? Whether A, B, C, D. 'Okay, let me solve. So in this question, actually, a rectangular open channel with width is equal to 5 meter. Here it is given 5 meter. Let us suppose this much flow depth. So and flow rate is given Q is equal to 0.75, oh sorry, 7.5 meter cube per second. 7.5 meter cube per second discharge is given. Now you need to calculate your critical depth. So critical depth is nothing but Q square by Z to the power 1 by 3, or you can say 0.33. So now, what is q? Small q. Small q is nothing but discharge per unit width. This is the formula. So small q is equal to 0.75 divided by 5. So it will come around 1.5 meter cube per second per meter, right? Or you can say meter square per second. Now you need to put in the formula. Yc is equal to 1.5 square divided by 9.81, 0.33. It will come around 0.61. 0.61 meter. So remember please, option C will be correct for this question. Now in the question number 6, question number 5, in case of open channel uniform flow, again we are studying here uniform flow. Remember please, the frictional force is balanced by pressure force, gravitational force, momentum force, and both B and C. So very important question, conceptual question. So please try to give your answer. And here you can assume the slope is very less. Theta is less. The channel slope. We are talking about this theta. So remember please, keeping in mind these things, you please try to calculate. Try to think. Question number 5. So you have 5 minutes for this question. Very important question. Okay, you are telling the gravitational force. Okay. Just please try to think on why you are not telling the pressure force and momentum force. Why it is not important? Just try to think on that. Then I will discuss. It might be chance to the pressure force also should be include, momentum force should also be include, but why we are neglecting here? So this thing also needs to be important to think about this question. And in this question, very simply, I will derive your frictional, or you can say the shear stress or frictional stress. Okay, let me discuss. So yes, you are correct. We consider only the gravitational force. Why pressure force? We are not consider. As you know here, theta is very very small. So that's why your hydro pressure distribution will be hydrostatic, which is normal, which is normally. This is not having the component in the flow direction. So that's why these things will be neglected. Now momentum force. Here is the uniform flow. Uniform flow. So momentum, we cannot apply the momentum equation here. So only remaining the gravitational force will uh, consider gravitational force for in case of open channel uniform flow to balance the frictional force. How you will balance? Let me explain here. So I want to explain above. First, I need to take space. So very simple derivation I will show you. Just wait few minutes. Okay. So here we need to consider one. Theta is very very small, remember, and open channel flow with uniform flow. Flow is uniform. Let us consider a section, or you can say the control volume. Let us take this is control volume here. So the weight of fluid in this control volume is how much? It is might be weight. How you will calculate? Weight is nothing but your unit weight into volume of the control volume. So if I consider the length of this control volume is delta x, or you can write L also. So here your gamma into area, cross sectional area, into your delta x. So this is the weight. Now the component of these things is gamma a delta x. This is cos theta if this is, and this is your sin theta, and this is your frictional force. Frictional force is nothing but ff. I write here, this is shear stress into area, shear stress into area. Area we will consider here perimeter into length, because your we consider here only your frictional force is acting on side surface as well as on bed, nothing on here. We consider the smooth bed, not like the bed formed due to the ripples and dunes. We are not considering here, only smooth sand bed. Okay, so here, so we can consider at the place of L is delta x, because here is acting delta ff, right? So now this component and this component we can compare, or we can, because this component, these two components should be because flow is uniform. Flow is uniform means what? The net force acting on a fluid element should be zero, because if net force will not be equal to zero, what will happen? The fluid will accelerate. So the fluid will not be uniform. So here we need, for uniform condition, the condition of uniformity, we need to equalize these things. Gamma A delta x sine theta is equal to shear stress perimeter into delta x. So delta x will be cancel out, and theta will be equal to your the slope. If very small, it will be equal to the slope of bed. So now gamma A S is equal to tau P. So your shear stress is equal to gamma A by P S. So you can write it gamma RF. This is a very well known equation, but this equation have lots of assumptions. Lots of assumptions. First is steady flow, uniform flow, incompressible flow. So you need to consider these three things. Now the shear stress acting due to only the side as well as bed. So this is another assumption, and theta is very small. This is the another assumption. So that's why your hydrostatic pressure is only acting vertically. So acting vertically means having some theta value, but which is we can neglect. There is no harm to neglect the things. So that's why. So these are the assumption uh, behind this equation. So please remember, before application, before using such type of equation, you need to know. Now moving with the next question. All things I have written here, why momentum force is not directly responsible for this frictional force and balance, whatever this question is telling, the all explanation is here. If you have doubt, you can uh, write me mail. Now the question number 6. What are the effects on the body with mass immersed in a fluid which is under motion? Lift and drag, drag and friction, lift and friction, friction and shear. Please try to calculate. My mail ID is OM or not, OM1996 at the rate itz.ac.in. So remember, please, if you have any doubt, you can write me. So question number 6, please try to give your answer. First try to understand the question, what is telling, then after you can write. Question number 6. Okay, you are telling the option A is correct. Okay, you are right. Obviously, drag and lift will act. But friction also will act, but this is not directly. That is the good answer is lift and drag here. Let me just draw what is actually the question is telling. So let us suppose one flow is like that. So water is flowing. Remember, the question is telling water or the fluid is under motion. Fluid is moving. A body is immersed in this, let us suppose a body is immersed like that. So what will happen? The force, the forces will act on the body, and that forces is represented by your drag force and the lift force. So explanation also I have given, very good explanation here I have given. So why lift and friction? The friction primarily affect the surface and oppose the motion, contributing to drag. The drag force, you're contributing the these things, friction things. Now the next question is again numerical. Okay, question number 7. At a hydraulic jump, the flow depth is R 0.4 and 3.6 meter at the upstream and downstream respectively. The channel is wide rectangular. The channel is wide rectangular. Find the discharge per unit width. G is equal to 9.81 meter per second square. Option A, B, C, D is given. So please try to calculate. Try to calculate and try to give your answer in the chat box for question number 7. So very important question. So please try to solve. Okay, please try to solve within 1 minute, then I will explain. Question number 7. If you remember the hydraulic jump criteria, that is a specific energy and a specific force criteria, you can easily you can tackle this question, otherwise it is very difficult. Okay, let me discuss question number 7. So here you know already one thing, the hydraulic, we are talking about hydraulic jump. So let us suppose at a particular location your hydraulic jump is, if I draw these things, so water is coming like that, and after that, so here depth is 0.4 meter and here depth is 0. Oh, that is 3.6 meter, right? So this is our study location. So by using these two things and we need to calculate a small q, that is in meter cube per second per meter. Here width is given, b is 1 meter is given already, remember please. So if b is 1 meter, your small q is equal to capital Q by b, so it will again need q. In this question your capital Q is equal to a small q because of b is 1. So remember these two things. Now here specific, we have the two equations. One is for a specific energy, another is a specific force. So we cannot use here the energy because here in the hydraulic jump energy losses. Here energy loss is happening. So that's why we don't know the how much energy loss happening. So here E1 and E2. Maybe we can calculate E1, but how we'll calculate E2 because we don't know how much energy losses here. So that's why we cannot use these things. But we can use the specific force formula here. Specific force at 1 and a specific force at 2. Now what is the formula? Specific energy formula you know very well, V square by 2Z, and your specific force formula is AH bar plus Q square by AZ. So this is the formula of your specific force. So at this equation, at this location, your A1 H1 bar plus Q, because discharge will be same, that is A1 and G equal to A2 S2 plus Q square here, remember, divided by A2 G. Now A1 value is Y into B, so that means Y, because B is 1 here, Y1, you will take Y here. So here Y1 is 0.4 into H1 is how much? That is the half of your depth. So 0.4 divided by 2 plus Q square we need to calculate. A1 again, A1 how much? 0.4 into 1. So we will not write here, and 9.81. equal to A2. A2 3.6 into 1 will not write here, and 3.6 divided by 2 H2 bar plus Q square divided by A2Z. A2 how much? 3.6 into 1 and will not write here, and G 9, because if you will multiply anything with 1 remain same. Now, so this will come around 2, that is 0.08 plus Q square divided by 0.4. If you will consider this 10, so 10 for the 40, it will come 4. Just for sake of simplicity, or let me calculate, because I have calculator, so I can calculate. So 9.81 into 0.4, so it is come 3.924 equal to 3.6 into 1.8. It will come around 6.48 plus Q square divided by 3.6 into 9.81, 35.316. Now 1 by 1 divided by 35.316, this will come whole year 0.028 Q square, 6.48. This will come 1 divided by 3.924. This will come 0.254 Q square, 0.08. So now 0.254 Q square minus 0.028 Q square equal to 6.48 minus 0.08. How much? It will come 6.48. So it will come, I can write directly here 6.4. Now 6. Oh, that is 0 point, not 6. This is 0. 0.25 minus 254 minus 0.028. It will come 0.226 Q square. Now Q square is equal to 6.4 divided by 0.226. 6.4 divided by 0.226. It will come 28.32. Q square is equal to. Now Q is equal to how much? If you will take under root, it will come around 5.3. So Q will come root under 28.32. It will 5.3 meter cube per second. Meter square meter cube per second per meter. You can write here, because initially I was just shown you, because B is equal to 1, so your Q is equal to also these things you can write. So your option A will be correct. So remember please, such type of question you can expect in your coming exam. So always remember. Now we'll move on the next question. Next question is Question number 8. Question number 8 is, for a given discharge in horizontal frictionless channel, for a given discharge in a horizontal frictionless channel, two depths may have the same specific force. These two depths are known as, here, these two depth, this 0.4 and 3.6, these two depth is known as specific depth, second depth, alternate depth, normal depths. So I want answer from your side. You can write in the chat box. So for question number 8, after this question I'll take 5-minute break, then we'll meet again. So please first you try to give your answer for question number 8. You have 2 minutes. Within 2 minutes, please try to think and then you write your answer. Okay, the answer of this question, let me. Okay, you are telling the alternate depth. So, not. Actually, we not know. We don't know. Uh, okay, here we know about the specific force is constant. If the specific energy is constant, then you can say the alternate depth. Here it is very clearly written the specific force is constant. So you can remember please, this such type of depth is known as secant depth. So remember please, here we are talking about a specific force and here we are talking about a specific energy. Specific energy is alternate depth and your secant and your specific force is known as secant depth. So remember such type of question, I think you can expect in your exam. So okay, I will show you the question number 9, then after I will go for 5-minute break. Question number 9 is, a rectangular wide channel convey 5 15 cubic of water at a depth of 2.5 meter. Calculate the critical energy of the flow. So please you try to calculate the critical energy. Then after I'll come within 5 minutes. So please try to calculate. Sure, I'll discuss about the critical depth and the normal depth. So let me first discuss. So critical depth is nothing but if your flow is okay, if the fluid number is equal to 1, let us suppose water is flowing in the channel. For calculating the fluid number, we need to require velocity as and g and hydraulic depth. Hydraulic depth is nothing but area by tau width. So if this value will come around 1, around not around exactly 1, so that depth is known as critical depth. If okay, that depth is known as critical depth. If your fluid number okay, that's it about the critical depth. If the flow or any flow above the critical depth is known as normal depth. Normal depth in case of if the slope is mild, if slope is steep, then might be not might be your normal depth will be below the your y normal here and y normal here below the critical depth in case of steep slope. So whatever we calculate the depth using the Manning's equations, so that type of depth we know, if you know the velocity and all everything in the Manning equation and you will calculate the depth, that depth is known as your normal depth if you want to know the practically. And your critical depth is nothing but that depth which having the fluid number is 1. So hope you got it. Or the critical depth having the lots of characteristics. At critical depth only. Okay, first you try to solve this question number 9. In question number 9 I will discuss that thing. In most of the practical cases, always flow always try to reach the normal flow. Remember please, normal depth. It might be slope mild or it might be steep and other. Always flow try to reach the normal. For some time, for a particular section, your flow may be critical, but entirely your flow will be normal depth flow. Based on that, we have one question also. I think question number next question. So please try to calculate the answer of this question number 9. Okay, let me discuss. Hope. So here a rectangular channel of 4 meter wide and water depth is given 2.5 meter. Discharge is given 15 meter cube per second. Critical energy we need to calculate here. So you know the energy formula, that is a specific energy, Y plus V square by 2Z. This is the, but here we need to calculate the critical thing. So we will use YC. Here we don't know the velocity. So one thing we know actually, discharge is equal to area into velocity. Area is equal to B into Y into velocity if rectangular things. Channel is rectangular. So velocity is equal to Q by By. We can write here Q square B square Y square 2Z. Here Y critical C. So first we need to calculate the YC is nothing but you know already Q square by Z power 0.33. So here Q will be discharge divided by width. Width is 4 already given. So after calculating Q value you will put here and you will get some. Let me exactly calculate. Your Q value will come around 3 point. Okay, let me exactly tell you. 15 divided by 4, 3.75 square divided by 9.81 power 0.33. So it will square divided by 9.81. So your 1.433 power 0.33 power 0.33. It will come around 1.127 meter. Now you need to put here. After putting this value, you will get YC will get here 1.13 or 1.127, and then after you can easily put here EC is equal to 1.13 plus Q is already given 15 square divided by 4 square into 1.13 square into 2 into 9.81. After calculating these things, we can easily get, let me first calculate, 16 into 1.13 square into 2 into 9.81, that is 400. This will come 400.84. Now 15 square divide 15 square divided by 400.84, 0.5613 plus 1.13. So 1.6 1.69 meter. So this is overall calculation how you will calculate. Now we'll move on the next question. Yes, here the same question is whatever I was explained previously. Question number 10. A mild slope channel is followed by a steep slope channel. The profile of gradually varied flow in the channel are option A M3 S2, M3 S3, M2 S1, option D M2 S2. So please try to write your answer in the chat box. You have 5 minutes for this question because very important question. Then I will explain what is M3 S2 S1. After that I will tell the answer. So please try to write your answer in the chat box. Okay, let me discuss. So here what is M3 actually? In mild slope, actually this is the representation of zone between or zone of flow you can say. Mild slope. Here is the critical. In mild slope, your normal depth above the critical depth. So this zone is known as M1, this is M2, this is M3. Similarly, in a steep flow, if your gradient slope gradient is steep, if this is steep, in such situation, this is your critical, and this is your normal. Why normal? So this is S1, this is S2, this is S3. So this is a zone of flow. Now the question is telling, what question is telling? Steep slope, that is a mild slope channel is followed by steep. One mild slope channel is given, then steep, like that. So here is the critical flow. Here is also the critical flow. Now you know already this is your normal flow line in the mild case, and in case of steep, this is your normal line. So initially, as I have told you, the flow always in the normal condition. So here in normal condition, the flow is come like that, and again it will try to reach the normal like that. So here is S1, S2, S3. Here is M1, M2, M3. So your flow depth in M2. Here in this steep slope, your flow depth is S2. So your final answer will be the flow profile look like M2, S2 as per the nomenclature of, as per this nomenclature. So this is the standard nomenclature, you can follow it. So the solution is M2S2. Now we'll move on the next question. Question number 11. For a pipe of radius r flowing half full under the action of gravity, the hydraulic depth is. What is hydraulic depth? If the situation is like that. So please try to calculate for question number 11. No, hydraulic depth we are talking, this is a hydraulic mean radius you are talking about, area by perimeter. We are talking, the question is asking about hydraulic depth, that is area by top width. A by P is a hydraulic radius. So I want to explain. So the pipe radius is given r. Let us suppose a pipe with radius r is given, right? Flowing half full, that is the top width is 2r, right? The hydraulic depth, area is equal to pi r square by 2, half area. Now hydraulic depth is nothing but area by top width, pi r square by 2 divided by 2r. So r will be cancelled out, pi r and this 2 to 4, that is pi r by 4. Option D will be correct for question number 11. Now we'll move on the next question, question number 12. Question number 12 is water discharge into a rectangular horizontal channel. Wait 1 minute. Yes, the discharge into rectangular channel from a sluice gate and undergoes a hydraulic jump. The channel is 25-meter wide and the flow depth and velocity before the jump are 2 meter and 9 meter per second respectively. The flow depth after the jump is. So please try to calculate for question number 12. Okay, let me just discuss. The rectangular horizontal channel means theta is equal to 0 is given here. Channel cross section is like that. The channel is 25-meter wide. 25-meter. The flow depth and velocity before the jump, that is a sluice gate is here. Like that. This is the bed of the channel. And water is plenty of water this side. And here is the depth is like that, this much. Then after jump is formed and then after like that. So here is y2, here is y1. So The flow depth and velocity before the jump means here is given y1 is equal to 2 meter and v1 is equal to 9 meter per second. The flow depth after the jump. Here you need to calculate, y2 need to calculate. So one formula is already given. When we will apply the momentum equation and all, then one formula will come out. Y2 is equal to y2 divided by y1, 1 by 2, 1 plus 8 fr1 square minus 1. What is fr1? v1 divided by g d. What is d? D is area by top width. What is area? If it is rectangular, then b into y divided by b, it will be y. So you can write v1 by gy1. So now, what is fr1? Velocity is 9 meter per second. G is given already, you know, if not given, 9.81, and what is y1 here is 2. When you will calculate, it will come, let me calculate. 9.81 into 2 root over 4.43. 9 divided by 4.43, it will come fr is equal to 2.03. Now you can put here y1 is given you already 2 by 2, 1 plus 8 into 2.03 square minus 1. So it will come 8 into 2.03 square into 8 plus 1 root over minus 1. Okay, it will come around y2 is equal to, if my calculation is not wrong, 4.8. Okay, 4.83. Option D should be correct. 4.8228 is coming meter. So like that you will calculate. Now we'll move on the question number 13. Question number 13 is the pre-jump float number for a particular flow in a horizontal rectangular channel is 8. What is the ratio of the secant depth? Same formula you can utilize. Within 1-2 minutes, if possible, please try to give your answer. Otherwise, I will explain. Similar formula, y2 by y1 equal to half bracket root over 1 plus 8 fr1 square minus 1. Okay. So here actually the pre-jump fruit number is given already. The pre-jump fruit number is given, FR1 is equal to 8. So remember please, the formula is like that. Sometimes you can write, you can forget the formula. 1 plus 8 FR1 square minus 1. This will be wrong because the formula, if y1 is above, if you will modify this formula, how it will look like? Y2 by 2, this formula. 1 plus 8 FR1 square minus 1. This should be wrong. This is wrong because here is Y2. Here should be FR2. If this will be FR2, that will be correct. So remember, the right side of equal to, if Y2, then fruit number, that is FR, will be 2. If right side is 1, then. So here we know the FR1. So we need to put right side Y1. So what we will do? Y2 by Y1 will do. When we will multiply, automatically will go this side. Now 1 plus, here is root 8 FR1 square minus 1. So 0.5, 1 plus 8 into 8 is already here. 8 square minus 1. So how it will calculate? So 8 cube plus 1, 8 cube plus 1, take root over 8 cube plus 1, then root over, oh no, 8 cube plus 1, then root over, okay, minus 1. I am using the gate calculator, so you please also try to use these things. 0.5. So your y2 by y1 is, because in the question is not given, so please remember 10.82, 10.82, because this is ratio, no unit. 10.82 in the question is not given. You need to calculate the whether y1 by y2 or y2 by y1. So you need to correct your answer with the matching with your options. So when you will calculate y1 by y2, it will become 1 by 10.82. So no option will matching with this. So that's why your this formula will be applicable and option A will be correct, 10.82. Remember please. Now we'll move on the question number 14, which is last question for today. The flow rate in a wide rectangular channel is 2.0 meter cube per second per meter width. That is, Q value is given 2.0 meter cube per second per meter. The channel bed slope is given 0.002. The Manning's roughness coefficient is given you 0.012. The slope of the channel is need to calculate. The slope of the channel need to calculate. You know the Manning's formula is what? Velocity is equal to 1 by n r to the power 2 by 3 s to the power 1 by 2. So how you will calculate? If wide rectangular channel, it means your r will be tends to y. How? R is equal to area by perimeter. B into y divided by B plus 2y. So wide rectangular channel means BB is much greater than y. So we can neglect these things. So B by Y divided by B, it will approximate Y is equal to approximately R is Y. So now we can modify the formula 1 by n y to the power 2 by 3 s to the power 1 by 2. We need to calculate what here s. So how we will calculate the velocity? Velocity, the discharge is equal to area into velocity. So this is B into Y into velocity. So Q divided by your B is equal to Y into velocity, and this is known as Q. And Y, what is the value of Y here? So Y is not given. The flow rate in the wide rectangular channel is this per meter width, the bed slope and the Manning's. Okay, so we need to calculate, oh, slope is given here. The slope is given. We need to calculate the Y. Because here what is asking, the slope of the channel is classified. The slope of the channel is classified means whether the slope is steep, whether the slope is mild, whether the slope is critical, whether the horizontal. How you will identify it? If your normal flow velocity, because normal flow will be greater than is yn, that is y critical, this condition, this will be mild. If it is yn is less than yc, this will be steep. So like that. So you need to calculate first of a normal. So that's why we calculate the normal flow using the Manning's. So from here you can very easily calculate the Manning's. So your velocity is equal to what? This value. So now you can put here, that is small q divided by y is equal to 1 by n into y to the power 2 by 3 s to the power, everything you know. From here you will calculate y value. Let's suppose it is coming x, capital X. Then you will apply the critical formula, that is yc barabar q square. Yc is equal to q square divided by g into 1 by 3. From here you will calculate y. Let us suppose it's coming capital Y. If the capital X is greater than capital Y, it will be mild. If your capital X will be less than capital Y, it will be steep. So in this question, let us see here the answer. So in this, here YC is coming 0.74 and YN is coming 0.6. So this is X value and this is Y value. So X value is less than Y value, capital Y value. So it means this is your steep slope. Remember please how we will calculate. Now the next question. Next question is very easy. So this is simply from your, you can such type of equation, you can say environmental engineering also. Calculate the terminal velocity. We are talking about here the terminal velocity of diameter 1 meter, rainfall droplet falling in a still air at a standard atmospheric pressure temperature 20 degree. The drag coefficient is given and the density of water and the density. You know the formula already. Let me just show you the formula. How you will, here is the formula is given. Because you know already the formula is like that, Vt square divided by 4 by 3 GD, 4 by 3 GD, rho of droplet particle, or here is the droplet, so that's why rho of water we can, particle means your droplet, and the rho of air divided by rho of particle, that is water, air, rho of air here. So like that. Now this formula we generally see, because your CD is equal to, because this question here is the CD. So CD, if your flow is laminar, if the flow is laminar, that is CD value is this. Remember please, CD value is 24 by RE. If your flow is fully turbulent, CD value is 0.4. So you will put here. And or RE, what is RE? RE you know already, this is given RE value. Means CD is equal to, in case of laminar, 24 divided by Vt into D into rho mu. So that's why here is a D square in terms, when we will write this formula in terms of dynamic viscosity, here will be d square, remember please. So the overall answer for this question, when you will calculate putting this formula, the answer will come 0.42. This is not tough task. So for today, that's all from my side. So thank you for today. We'll meet in the next class, hope on 16. So NPTEL team will intimate you through your mail. So thank you, bye bye.